So let's just talk about the circular queue and all of its operations. So the circular queue is a linear data structure that also follows the FIFO or the first in first out. So this is same as the normal queue, but the only difference is that the end of the queue connected back to the front and it forms a circle. So in a normal queue we have the front pointer and also we have the rear pointer. So initially both of them will point to -1. Now suppose we perform the enqueue operation and we enqueue the value 10. So that means the value 10 will be stored in the first position of the array at the index 0, and the front will point to the 0th index and the rear also will point to this 0th index. So also we can enqueue the value 20. So the rear will be incremented and the value will be inserted right here in that position. So this way we can enqueue 30, we can enqueue 40 and 50. So the rear will point to this last position. So now you can see our queue is full. So we cannot add any more elements to the queue. Now if we perform the dequeue operation, so the dequeue will remove the element from the front. So that means the value 10 will be removed and the front will point to the next position. So this way we can again call the dequeue function. So now this value 20 will also be removed and the front will point to the next position. Now the problem with the normal queue is that even though we have two positions empty, but still if we try to enqueue new value, it will give us the error that the queue is full because the rear is pointing at the last position of the array. So this is the main drawback in case of the normal queue. We cannot efficiently utilize the memory in case of the normal queue. Now to solve this problem we can use the circular queue. So in circular queue the end of the queue connected back to the front. So that means this end will be connected back to the front of the queue. Now even though the rear pointer is pointing to the last position of the array, but still the rear has the next position. So the next position of the rear will be the 0th index. So now we can use the circular queue and we can efficiently utilize these free spaces. That means we can perform the enqueue operation and we can enqueue new value like the value 60. So this value 60 will be inserted right here at the first position. So the circular queue will efficiently utilize the free space in our queue. So in a circular queue we also have the same operations as in a normal queue. Here also we can perform the enqueue operation, we can perform the dequeue operation, and also we have the functions like isFull. So we can check if our queue is full or not, and also we have the isEmpty to check if the queue is empty or not, and also we can get the values from the front of the queue and also we can get the value from the rear of the queue. So let's just see how we can implement all of these operations. So in a circular queue, here also we have the indexing which starts from 0. Now initially because our queue will be empty, so the rear pointer and the front pointer both will point to this -1, which indicates that our circular queue is empty. So first of all let's just see how we can implement the enqueue operation. So here is the enqueue function. So here we're gonna pass the value that we wanted to add into our queue. So first of all we're gonna check if the queue is full or not. So if the queue is full, then we're gonna print queue is full and then we're gonna return. Otherwise we're gonna check if the queue is empty. Queue is empty, that means both of these pointers are pointing to -1. So in case the queue is empty, so we're gonna initialize 0 to both the front and the rear. That means both of these pointers will point to this 0th index. Otherwise if the queue was not empty, in that case we're gonna move the rear to the next position. So this is the formula to get the next position in case of the circular queue. So in a normal queue we can just add 1 to the queue to get the next position, but in the circular queue because the end of the queue is connected back to the front, so that's why here we have to module that with the size of the array. So this way when the rear is pointing to the last position, so the next of this rear will then point back to the 0th position. So that's why we are getting the module with the size of the array. After that, we can insert our value at the rear index position of the array. So suppose we are calling the enqueue function and we are enqueuing the value 10. So because the queue is empty, so both the front and the rear pointer will be pointing to the 0th position. So here the rear pointer and the front pointer will point to this 0th position, and then in that position we can store the value. So that means the value 10 will be stored right here in the 0th position. So similarly we can enqueue the value 20, so the rear will be incremented to the next position, and in that position we're gonna store the value 20. So this way we can enqueue the value 30, 40 and 50, and the rear will be incremented accordingly. Now in a case where the rear is pointing to the last position and we have free space at the beginning of the queue, so in that case if we perform the enqueue with the value 60, so the next position of the rear will be calculated. So the next position will be rear plus 1 module size. So the next position will point back to this first index, the 0th index. So the value 60 will be inserted right here in the first position. So that means you are efficiently utilizing the free space in the circular queue. So this is the advantage of using the circular queue. So let's just see how we can perform the dequeue operation. That means how we can remove element from the front of the queue. So here is the function to perform the dequeue operation. So first of all we're gonna check if the queue is empty or not. So if the queue is empty, then we're gonna print queue is empty and then we're gonna return. Otherwise we're gonna extract the value from the front of the queue. So from the front of the queue we're gonna extract the value, and then we're gonna check if the front is equal to rear. So when the front and rear is pointing to the same index, that means we have only one value in our queue. So if we remove this value, then our queue will be empty. So that means we have to reset the queue. So that means both the front and the rear should point to -1 when the queue is empty. So in that case both of these pointers will be pointing to -1 because the queue will be empty. Now otherwise if we have multiple elements, so that means the front is pointing to this one and the rear is pointing to this one. So in that case we have to only remove the element from the front index and then we're gonna increment the front. Now here incrementing the front is not only front plus 1, we have to module that by the size of the array, because we are using circular queue because the end is connected back to the front. So that means the front will be pointing to the next position. So if we call the dequeue, this will remove the value 30. So this way we can again call the dequeue. So this time it will return the value 40. So this value will be returned and the front will be pointing to the next position. Now again if we call the dequeue function, so the 50 will be returned and the front pointer will be pointing to the next position. So now the next position will be back to the front of the queue because this is one circular queue. So this is how the dequeue operation will work. And this way also we can implement the isFull function. So this function used to check whether our queue is full or not. So in this function we are simply going to check if the next rear position is equal to the front, then we're gonna say that our queue is full. So the next rear position we have to calculate by moduling the size of the array. So the rear plus 1 module size will get us the next position of the rear. So if that is equal to the front pointer, then we can say that our queue is full. So suppose the rear is pointing to the last position and the front is pointing to the first position, and all of our positions are filled with values. Now here you can see the next position of the rear is the front position. So that means we can say that our queue is full. We cannot add any more values into our queue. And also we have the isEmpty function So this function will check if the queue is empty or not. So here we are simply going to check if the front pointer is pointing to -1, that means our queue is empty. So when the front pointer is pointing to this -1, then only we can say that our circular queue is empty. Otherwise, if that is pointing to any index of our array, then we can say that the circular queue is not empty. And also we can only access the value from the front of the queue. So this is the function to get the value from the front of the queue. So first of all, we're gonna call the function isEmpty to check if the queue is empty or not. So when the queue is empty, then we're gonna return -1. Otherwise, we're gonna return the value from the front position of the queue. So similarly, also we can get the value from the rear position of the queue. So here also we're gonna do the same. First of all, we're gonna check if the queue is empty or not. So if the queue is empty, then we're gonna simply return -1. So otherwise, we're gonna return the value at the rear index. So this way, the circular queue can be really useful to efficiently utilize the free space in our queue. So this way we can implement the Enqueue operation, the Dequeue operation, and also the isFull, isEmpty, and also we can get the value from the front of the queue and also from the rear of the queue. So hope you understand the concept. See you in the next one. Take care.